November 10th, equations with super scary fractions. So let's look at some of the examples. X plus 4 is equal to 13 halves. Rather than deal with this fraction by subtracting 4 from both sides and having to convert 4 into halves, so I really subtract 8 halves, which gives me 5 halves, I can avoid that by multiplying every single term by the denominator of 2. So this gives me 2x plus 8 is equal to 13. And then when I subtract 8 from both sides, I get 2x is equal to 5. And when I divide by 2, x is equal to 5 halves, just like I predicted. Moving to the right, here we have a 20, a 3, and a 4. Is that same trick going to work? Well, it turns out we can do it one step at a time. For example, what if I first multiply all of the numerators by 3 to cancel out the 3? Then I end up with 57 over 20 is equal to 2x plus 9 over 4. I multiplied by 3 first. The next thing I could do is multiply by 4 to cancel out the fourths. So this gives me 228 divided by 20 is equal to 8x plus 9. And if I wanted to, the final thing I could do is multiply by 20 to cancel these out. So if I do so, I'm left with 228 on the left, 160x, and 180. There are other ways to do this, but multiplying by each of the denominators successively, starting with the smallest, I have canceled out all of my fractions. Now when I subtract 180 from both sides, I have 48 is equal to 160x. When I divide both sides by 160, I can reduce this. I know that 8 is a factor for both, so if I divide by 8, I have 6 over 20. From these two, I can divide both by 2, and I have 3 over 10. Another example, here with 73/18, 2/3, and 3 halves. Instead, I can look for what's called the least common multiple. That is, the smallest number that all three of these denominators multiply into. So if I start with the largest one, 18, I can ask myself, do these other denominators multiply into 18? Does 3 times something equal 18? And the answer is yes. Does 2 times something equal 18? So then, instead of multiplying by 2, then by 3, then by 18, I can look to convert all three fractions to 18ths. So I have 73 over 18 is equal to multiply by 6, I now have negative 12 over 18, x, and then I multiply this one by 9, so 27 over 18. Then, when I multiply all three by 18, I'm left with 73 is equal to negative 12x plus 27. From here, it's your standard two-step equation, minus 27 minus 27. This gives me 46, 48, is equal to negative 12x. When I divide by negative 12, I get negative 4 is equal to x. Here on the right, the same technique can be applied. To get rid of the thirds and the ninths, I can convert the thirds to ninths. So this gives me 15 ninths x plus 12 ninths is equal to negative 8 ninths. And when I multiply all three by 9, I get 15x plus 12 is equal to negative 8. And here I can subtract 12 from both sides. I have 15x is equal to negative 20. And if I divide by 15, I get x is equal to negative 20 over 15, which can be reduced because they have a common factor of 5. So I get negative 4 over 3.